Are you tired of mundane content? Fed up with cookie-cutter animations that lack personality? Well, say goodbye to dull visuals, and hello to Champ, the game changer in animation technology. Introducing Champ, your ultimate solution for controllable and consistent human image animation with 3D parametric guidance. With Champ, you're not just creating animations, you're crafting stories, unleashing creativity and captivating audiences like never before. Forget TikTok trends and generic filters. With Champ, you can bring any image to life and make it dance, emote, and express just like you. Whether you're a content creator, marketer, educator, or simply someone with a story to tell, Champ empowers you to elevate your visuals and stand out in a crowded digital world. Ready to revolutionize your content? Try Champ today and unleash the power of animated storytelling. Champ, where creativity knows no bounds.
Another day, another tool. So let's start with the installation. Navigate to the folder where you want to install. Point to address bar and type cmd, press enter to pull up the command prompt. First, we need to clone the repository. So use the following command. Once the cloning is complete, switch to the directory. Next, we need to create a virtual environment. So use this command and press enter. So once the virtual environment is created, we need to activate the virtual environment. For that, we use the command mentioned in step 4. You should see this venv. Now, we need to install the requirements. So copy this command and after pasting, press enter. So while the installation is in progress, navigate to the GitHub page, scroll down where it says download pre-trained models. Now we need to download the models according to this. So first create a folder, pre-trained models. Next, we need to create some subfolders within it. So 1, 2, 3, and 4. 4 subfolders we have to create. The folders are created. Now we need to download the pre-trained weights. So these checkpoints needs to go in the champ folder, this folder. So you can use the download button against each of these and you can download them except for example data. Rest, all of them can be downloaded in the gem folder. Similarly, repeat the step for stable diffusion should go in the stable diffusion -1-5 folder. VAE, SDVAE, FT, MSE, the file should go here, and image encoder should go in the image encoder. Now, there is one specific instruction that you should follow while downloading the config.json file. When you click on download, you will see it automatically prepends the folder name with the file. So while saving, when you are saving it, just remove this So it should look like config.json file and then download the file. After you have finished downloading, there is one additional file that we need to save in the root folder. So for that, open this link, our checkpoints. There is one example data that they have provided. So we are going to use that to understand how this tool functions. So download this and put it in the root directory outside of pre-trained models. So that should be saved here. So example data.zip file should be saved in the champ folder. So you can download it, save it, and extract it. So once you have downloaded the files, you should see one example underscore data folder. After the extraction, inside that you will see motions and reference images. Next, you should see pre-trained models. There are 4 folders, and you should download all the files. Make sure this should look like config.json. Same for this. So validate it against this information. It should look exactly like this. So the installation has finished. Next, we see that Torch with CUDA is not installed. So there is one additional step that we have to do, which is step 7. Copy this command, paste, and press enter. This will install the correct version of Torch. So while the installation is in progress, I'm going to use Automatic 1111 Web UI to generate an image, which I will be using to generate the video. So I've entered these parameters. I'm using Cardos Anime checkpoint, and I have generated this image based on these parameters. I will also provide this in the README file, which you can refer and generate on your own. The installation is all completed. When I reviewed the guide, it says it has been tested on very high-end GPUs, A100 and RTX 3090, which not everyone have. I also have RTX 4060, which comes with 8 GB VRAM. And the reason it requires a lot of memory is we look at the example data and motions. So these motions have a lot of frames that we see. That's the reason why it requires huge amount of memory. So what I did was I picked one of the motion, and just for the testing purpose, I split the frames in the batch of 20 and 40. So like in the first one to test out the functionality, I use 20 frames, next 20 frames, and then 40 frames, and the remaining one in the last folder. That is the batch number 6. So I tested using this approach and it worked fine. The system did not complain, neither did the tool. There were no errors. So what I'm going to do is I'm also going to upload this batch, and I will put it on Drive so that you can also download and test using these. Next, I have generated one of the images, which I put it in the ref images folder. So this is the particular image. Now we will see how we can use this tool. So the documentation says that we have to use the following command to generate the video using the input image. So there is one file that is available in configs folder, that is inference.yaml. So let's go to configs folder. open this file in any text editor. So I've not gone through all the parameters to understand how these can be customized. The only thing I'm interested in where to specify the input image and how to specify the motion folder. So these are the two variables under data where we have to specify the reference image and the motion. So let's copy the name of the reference image. The PNG file. Next, we need to specify the motion folder. So I'm going to pick up this folder name and use it. Now go to the root directory, gem, type cmd and press enter. Every time you want to use this tool, you have to activate the virtual environment. Right? And then we need the command. So I've added this information in the README file. You can refer that as well. So as we see on 8 GB of VRAM card, this does not come up with any error, and we still have enough VRAM available to do the processing. So I've tested this with 20 frames in one batch as well as 40 frames in one batch, and it works fine. So you can follow the same approach if you want to try out the other motions which are present in the example data. So you can organize the frames which are present in each of these folders in the batch of 40 each if you have a good graphic card with at least 8 GB of VRAM. But I believe with less number of frames, it should also work on 6 GB of VRAM card. So once this process is completed, we will review the output. Thank you.